Okay. It's still dark. Ooh, let's turn darkness. There we go. That's better. There we go. That's better.
This meeting is being recorded.
Okay, we're going to start chapter 10 today. Okay. Oh, let me take a roll first. Take attendance. Okay. Cassidy.
Here.
Okay, Alejandro.
Here.
Liliana.
Here.
Lainey.
Here.
Sandra. Romeo. Brenda.
Here.
Jasmine. Oh, Romeo's here. Okay. Thanks. Okay, Jasmine. Is Jasmine here? Josue. Jade.
Here.
Valerie.
Here.
Edsel.
Here.
Is Edsel here? Is Joel here?
Yeah.
Monique.
Here.
Salvador.
Here.
Caitlin.
Here.
Kayla.
Here.
Romeo. Ramos. Oh, Romeo. Is Juliet here? I have to tell the joke at least once. At least once. Come on. Okay. Paola
Here.
and Ricardo.
Here.
Anybody did not call? Cassandra, Jasmine, Josue, Edsel, and Romeo Ramos. None of them? They don't want to show up today? Fine. Forget them. See how it is. Okay, we're going to start chapter 10 today, as I already said. And we're going to go over 10.1. Okay. Ooh. I do want to share something with you though in the chat room, in the chat box, in the chat. Oh, Edsel was here a second ago? Interesting. Oh, hopefully he comes back. He is back.
Okay, sorry if you guys were.
He's back. Okay, well, that's good. Thank you. Thank you for letting me know. Okay. Okay, so I want to share a file with you guys real quick. So let's go. This PC, I don't know, documents. Let's go to my stuff. There it is. Okay, see if this is right. I think this is right. So I posted in the chat box a PDF of a sample space for cards. So I can open this thing. Okay, hopefully you can download that. But it's just so you know what a deck of cards looks like. Are you able to download that from the chat box? Is anybody able to grab that off the chat box?
Put
it in the chat box?
Did it work?
I don't think you put it in the chat box.
You didn't put it in the
yet.
chat box?
No, I don't
Got
see
it.
It's not there?
You probably put it to
Oh, I
message.
probably put it to one person. Okay, so let me fix that. Okay, so I ask. Okay, where do I want to go here? Okay, so now it says from me to everyone. Nobody got? It says that.
Yeah, I got it. It's a PDF that we downloaded.
Yeah, it's at 2:09 p.m. Okay, right before Lainey said no problem. I said,
I don't see it.
here's the card sample space. So I can upload it again if you want. Try. I can try to send it again. So, didn't get it. It says cards sample space. Open. Open. It says file was sent successfully. You just click download on it. Oh, Richard sent it too. Everybody sent it. Richard sent it as well. So, okay. You don't see the link. It's in the chat box. There's 3 of them now. You can't see it either. Okay. Then I'll just post it on Canvas then. Let's do that real quick here. Let's go to announcements. And then I'm going to go add announcement. I'm going to go card, playing cards. Maybe I'll put playing cards. Playing card sample space. And I'm going to say choose file. And I'm going to go to my documents. And reference. Yeah, reference. I'm going to go there. I'm going to say standard card deck. Save. Okay, so if you didn't get in the chat box, hopefully you got it on Canvas now. Okay. It's also going to be in your notes, so keep that in mind as well. Okay. So let's go to the notes. Okay, so here's today's notes. Okay, chapter 10, probability. Okay, the probability of a specified event is the chance or likelihood that that event will occur. An experiment is a repeatable process. For example, flipping a coin repeatedly to obtain the probability of flipping a head. That's an experiment. Okay, a subjective probability is an educated guess. Okay, so this is just a guess. For example, 9% of people who love sweets preferred chocolate. Although there is truth to this, on the other hand, there are plenty of people who enjoy sweets but do not prefer chocolate. Okay, theoretical probability is what would in theory happen over a period of time. For example, where you have n equally likely possible outcomes and m is the total number of ways that occur. So flipping a coin, you have, or flipping, let's say, heads, getting heads on a coin. Would be one head for two outcomes, okay? It's the number of desired results over the number of possible results, and that should be 1/2. Okay, so this is a theoretical probability. Okay, in theory, we should get, if we were to repeatedly flip a coin, we should repeatedly, over a long run, the theoretical probability should be 1/2. So say that I flipped a coin 10 times, the theoretical probability should be 5/10 or 1/2. Okay, so that's the theoretical probability. Now the experimental probability may not be that. It may be 6 heads out of 10, you know, or 7 heads out of 10, or 4 heads out of 10. That's the experimental probability. Okay, but the theoretical probability should be, that we're going to compare it to, is what's the long run average? Well, we should get 1/2 heads and 1/2 tails if heads and tails are equally likely to occur. Okay. Okay, the result of an experiment is called an outcome. Okay, so that's the result of an experiment. And so an event, okay, is any particular outcome or group of events. So we would say that the probability of an event E occurring is the desired results over the total outcomes. Well, total outcomes possible. Okay. Okay, a simple event is an event with one outcome. Okay, well, it is simple. A sample space is a set of all possible simple events. So we would say that the sample space for a coin, okay, two-sided coin would be, and I'll put it in these curvy brackets, heads and tails. That's the sample space, okay? Sample space is heads. Okay, heads and tails. Okay, so that's all the possible outcomes, right? What is the sample space for rolling a die? Well, it's how many outcomes are there? Well, there's 6 outcomes, right? So there's 1, 2, 3, 4, 5, 6. Here's the sample space right here. Okay, boom, 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 boom. There's the sample space. Okay, and if we wanted to, we could just list it off as the numbers that correlate to the sides of a die. We could say that this is 1, 2, 3, 4, 5, and 6. Okay. Okay, basic probability. Give all the outcomes that are equally likely. Given all the outcomes that are equally likely, we can compute the probability of an event by the given formula. The probability of an event E occurring is the number of ways event E can occur, or the desired outcomes, how many ways that we can get the desired outcomes, over the total number of outcomes. Okay, so let's revisit 10.1 where we have 6-sided die. What's the probability of rolling a 3? Well, what's the sample space? The sample space of a 6-sided die is 1, 2, 3, 4, 5, and 6. And so what's the probability of rolling a 3? Well, how many 3s are there? Well, there's 1 3 out of a total of how many possible outcomes? 6 possible outcomes. There's one desired result. There's one desired result. The number of desired results is 1. That's a 3. After over how many possible outcomes? 6. Okay, so 1, 6. Okay. Okay. What is the probability of rolling a number larger than 4? Okay, well, what's the ones that's larger than 4 here? Well, how about 5 and 6? That's larger than 4. So I would say here that the probability, okay, the probability of, we'll say x is the amount, x is greater than 4, okay? X would be the number on the die. Okay, probability that x is greater than 4 is 2. There's 2 that fit my criteria. 2 possible outcomes that fit my criteria. The number of ways that I could get it to be true is 2 out of a total 6, and I can reduce that. Always reduce your fractions. Okay, reduce, reuse, recycle. Okay, so always reduce your fractions. So that is 1/3. Okay, 1/3. Okay, what's the probability of rolling an even number? Okay, well, what was our sample space? Our sample space, again, was 1, 2, 3, 4, 5, 6. So what's the probability of rolling an even number? Any ideas? Yep, 3 out of 6. Very good, Lainey. 3 out of 6, which reduces to what? Close. What's 6 divided by 3? There you go. 1/2. Okay, here is a standard 52 playing card deck. That's what I gave you. Okay, as the download. Okay, I gave you the sample space to a 52 card playing deck. There are 4 suits. Okay, hearts, spades, clubs, and diamonds. Okay, so this is, okay, so this is called a spade. This is a spade. This is a club. Okay, this is a heart. Imagine that. and this is a diamond. Okay. And I always go over this because I always have at least one person that says, yeah, I've never really played with playing cards, and I don't know how they operate. So I'm sure that, you know, in a class of 18, I'm sure everybody's seen playing cards at one point in time in their life, but they may not readily know exactly how many cards there are, how many suits there are, or how many are in each suit. How many, if this is 52, then how many spades are there? Well, there's 13. There's 13 here. There's 13 here, 13 here, 13 here. There's 13 here and 13 here. Okay. How many aces are there? How many aces are there? Yeah, there's 4, exactly. Yes, there's only 4, right? So look at the aces, there's 4 of those. But if you look at, well, how many spades are there? Well, there's 13. So we've got a lot of 4s, a lot of 13s, 52. And what's 52? 52 is 13 times 4. So, okay, there's a lot of things that are going to reduce by 13. Okay, when we do probabilities involving cards. Okay, Bucky has a standard deck of 52 cards and wants his friend Satchel to draw a card. Okay. After Satchel draws a card, he puts it back in the deck. Okay. What is the probability of Satchel drawing an ace from a deck of 52 cards? What does that say about the probability of drawing one type of card? Okay, so what's the probability of drawing an ace? Well, how many aces are there? You just said that. 4, yeah, 4. And how many total cards? 52. Thank you, Lainey. And what does that reduce to? Again, always reduce your fractions. Always reduce your fractions. Yeah, 1 out of 13, exactly. Boom. Nice. So now, what would be the probability of getting a 2? Same thing. What would be the probability of getting a queen? Same thing. What would be the probability of getting a jack? Same thing. King, same thing. 1 out of 13. Okay. What would be the probability of getting a heart? Probability of getting a heart. 13 out of 52, which reduces to 1/4. And does that not make sense because it's 1/4 of the deck is hearts?
Yes.
Thank you, Alejandro. Yes, you are right, sir. Okay. A survey was taken of drivers admitting to running a red light last year. What? Should not be doing that. What is wrong with that? The number of yes responses was 500, and the number of no responses was 213. So we have 500 yeses. These are the bad boys. Bad boys, bad boys. What you gonna do? What you gonna do when they come for you? And we had the Lightning McQueen. Okay, and 213 no's, right? No's. Okay, 500 yeses and 213 no's. Okay, find the probability that if a person chosen at random, he or she has run a red light. Okay, so probability of being a criminal. Okay, the probability of being a criminal is, you're breaking the law. Criminal. Okay, is what? It's the number of outcomes that we want. We want the desired outcomes, which is how many criminals there are here. Okay, what goes on the top?
113.
No.
500.
500, yeah, 500. We have 500 people who broke the law by running a red light. Out of the total possible people, well, how many people are there here?
713.
Yeah, very good. 713, exactly. Okay, and if I were to plug this into my wrong calculator. Let's do that. Okay, if I plug this in my calculator, I would get 500 divided by 713. Boy. Okay, and that is equal to 0.701. I'm always going to go out 3 decimal points. Okay, 3 decimal points. So 0.701, which is 70.1% of the people are breaking the law. Okay, that is just not good. What's wrong with our society? Okay, so 70.1% of the people are running the red lights. Okay, it's not good. It's a lot of revenue there if you get caught. It's a lot. It's how the city gets rich. Okay, probability rules. Okay, an impossible event has a probability of 0. Okay, but if it right. Okay, probability of 0. Okay, so what's the probability, okay, of drawing a Charmander from a standard deck of 52 cards? What's the probability of getting a Charmander from a standard deck of 52 cards? Yeah, exactly. It's wrong deck, right? 0. 0, it's not Pokemon deck. It's a standard 52 deck. So 0 out of 52, which is 0. Okay. Okay. Okay, what is the probability? If something is certain to happen, okay, then its probability is 1. Okay, so what's the probability, okay, of, let's see, of, loving Professor Holtman's class and I'm just going to put this up here. It's 18 out of 18. Okay, I'm just going to let you know that right now. It's 18 out of, okay, so the probability of loving Professor Holtman's class is 18 out of 18. Okay, it's just, I'm just polling the people that are here today. Okay, because the people that are not here, they don't matter. They don't love my class enough to show up. So, boom, that's 1. Everybody loves my class. Okay, that's all I'm saying. Even with the apostrophe. Okay, makes sense? Okay, the probability of any event must be between 0 and 1. Okay, must be between 0 and 1. Okay, so we would say that the probability of an event must be between 0 and 1. It's basically a fraction that we can turn into a decimal. So we get a frac that turns into a dec that turns into a percentage. Okay, so, and we can leave them as fracs, decimals, or percentages. Sometimes we like to leave them as percentages because it's just easier to think of something out of 100, okay, in our base 10 brains. Okay, that's 10.1. That's all I have planned for today. We got 10.2 to go over on Wednesday. And so make sure that you do your homework. You have plenty of time. You got an hour to work on your homework. So I will see you guys on Wednesday. Okay? Talk to you then. Okay.
Thank you, Professor.
Yeah, you're welcome. See you guys on Wednesday. Cassidy.